This is part 3 of our end-to-end tutorial on FreeCAD. This is taken from the FreeCAD for Inventors book, and in this section, part 3, we're going to cover setting up the path job to create the CNC G-code instructions, and then actually cut the model out of some aluminum in the shop. In parts 1 and 2, we looked at using an image plane to import an image and sketch over it to create the half model. And in part 2, we looked at some of the mirroring options in part design and the part workbench to create the left half of the model and the chamfers on the edges. So if you need to jump back and catch up, please do. Okay, so let's go ahead and jump into it. If you remember, I left off where we had a fusion object, which is the complete we did a refinement on the shape in order to remove the center line, and I'm going to turn that off and turn on our base object. And this is the one that I'm going to use as the base object for the part or for the path job. I could use either one, but I'm going to keep using this one so that if I want to tweak anything in the sketch, I don't have to set up the job again. So I'm going to switch to the path workbench, and I'm going to select the fusion object and create the path job. It'll ask me for the base model and the template, and I think I've got a template set up for aluminum, but I'm going to say none, and we'll set up everything manually here. Okay, so the first thing that it's asking me to do is to set up the material, the black box is indicating the shape of the material that we're going to be cutting from. And this works fine for me just like it is. I don't need to change anything. If I wanted to reposition the model in the stock or set the coordinates for how the CNC machine is going to work, I could do that here. So it's very common to say like the bottom left corner would be the 0, 0 point, or the bottom left bottom of the material. In this case, I'm going to leave my 0, 0 as the center of the model, and it's really its preference. It's however you prefer to work with your machine. So I'm going to leave this just like it is, and we'll say OK. And then the next thing is to create an operation which will do the cutting around the outside. But before I can do that, I need to tell it what kind of a tool is going to be used to do that. So if I open up my job node, you'll see that I have a default tool created in here. And when you create a job from scratch, it automatically gives you a tool to start with. This should always be edited to reflect a real tool. So I'm going to open it up. And there's a tab at the bottom which indicates the diameter of the tool. The tool that I'm going to use is actually, it's an 1/8 inch cutter. So I want this to be 1/8 of an inch diameter. So it gives me 3.17 millimeters, which is correct. And this is an end mill. And I can say OK. Now, keep in mind that what we're actually setting up here is a tool controller, and there's a difference between a tool and a tool controller. A tool indicates is the physical object that does the cutting. The tool controller is a usage of a tool like that. So the difference between a tool and a tool controller is the controller contains the feed rate and the spindle speed as well as the geometry for the tool. So in this case, I want to run at, we're going to run at 140 millimeters per sec. Actually, it's going to be, we're going to run at 140 millimeters per minute. Okay, and you'll see that what this is doing is it's inserting millimeters per second, because this is the default unit that is FreeCAD's base unit for distance is the millimeter, and for time is the second. But for CNC, we're always working in millimeters per minute. So what I need to do is go to the Edit menu and Preferences. you need to go to the Units tab, and I'm going to select Metric, Small Parts, and CNC, and you'll see that it's indicating millimeters and millimeters per minute. Okay, now if I go back to my tool controller, you'll see that my horizontal feed is now showing in millimeters per minute, and I want this at 140. And I know that just from cutting this kind of material before. And I'll set the same thing for the vertical feed rate. And I'll set my spindle speed as well. This is machine dependent. In my case, I use a VFD, and so I'm always setting my spindle speed to 3000, and then I adjust it with the VFD or the manual speed on the mill. So that's just the configuration that my mill needs to cut aluminum. But I've now got a configured tool controller, and I'm going to actually change the name on this too, because the name of the tool will get reflected on the in the G code. So I'm going to say 1/8 inch end mill. Okay. So now I've got a tool that I can work with, and I've got a job which defines my stock. And the next thing I need to do is to configure the operations for this. So for our purposes, all we need to do is to cut the outside perimeter. That's a very easy operation. It's called a contour. And if you don't even need to select anything from the model, if you just select the contour, it'll use the base shape. And if you click on apply, you'll see that the green lines are generated showing the tool path where the tool is going to travel. And it automatically used the depth of the material to calculate the step downs, and its default step downs are coming from the tool diameter, and this might be too aggressive for that 1/8 inch cutter. So I'm probably going to change these. So right now it's stepping down 3.17 millimeters per pass, and that's more than I want to go. So I'm going to click on this. Once again, they show up behind. I'm going to discard that value, and I'm just going to step down 1 millimeter at a time. And okay, so now you can see I have more step down passes in here. Okay, so that should work right there. I could probably go out to the machine, clamp in a piece of aluminum, and run the job, and it would cut out. But the problem is going to be that right at the end of the cut, the batarang shape is no longer going to be. You can imagine that I've got clamps holding this piece of aluminum to the table, and as I finish up the cut, the model itself is no longer going to be connected to the stock, and so it's going to break loose, and it's either going to twist into the cutter and damage the model, or break the cutter, or it's going to fly off the table and hurt me. So what I want to do is I want to leave a little bit of material behind to hold the model in place so that I can then cut it out, do the final cutting manually, and we call that a holding tag. So probably the best place on a model, if you have a choice of placing them, place the holding tags on a straight edge. They're a little easier to cut off and to sand smooth afterwards. So I'm going to open up the Operations tab, select the contour, and then go under Path, Dress Up, Tag Dress Up. And the way that a dress up works is that it modifies the existing path and adds additional features to it. So you'll see that these green balls come in, and this is where, if I zoom in on one of these, you'll see that it's modifying the path so that the cutter comes in this way, then it hops up over this space and then continues on. So it leaves a little bit of material behind. So these two are fine. They're probably where I want them. These two I don't really need, and I think that 2 tags alone will be fine. So if you select these in the list, they'll turn orange so you can see which one is which. So this one I'm going to disable it, and this one I'm going to disable it, and apply, and say OK. And now you can see that my base path, there's no holding tag here and here, but I've still got them there. like that. Okay, and if you want, you can go back into the tag dress up and modify something. I think 2.5 millimeters is a little higher than it needs to be, so I'm going to back that off to 1.5 millimeters. And I don't think it needs to be this wide either, so I'm going to run it to about 3.3. So you have some control over the shape of the tag. You can have a rounded profile on it and change the shape. Okay. So now I've got a path to cut it out. I'm going to hold the material in place. The next step is to generate G-code from this, and that's called post-processing. And a post-processor is, again, specific to the kind of machine. So I'm going to open up my job again, and we're going to switch to output. And you'll see that I already selected or automatically selected LinuxCNC because my preferences are set up to do that. And I do not want to be running in inches. I want to be running in metric. And so I want no header. And if I specify the output location, I can even specify the file name. So I'm going to say that this is batarang.ngc. And I've given it the location on my home server so that my CNC machine can find it there. And so that looks all good. And so, okay. Now I can select the job and I can use the post-processing button. It'll pop up. It's defaulting the file name. It's finding the correct location. And if I save the file, it'll allow me to preview the G-code. So again, it's showing me my 1/8 inch end mill here in the comments. It's doing a tool change to T1 for that. It's setting the spindle speed to 3000, and then it's proceeding at 140 millimeters per minute through all the moves to finish it. We could also take the job and hit the simulate button. And I'm going to back off the accuracy a little bit. If the accuracy is too high, things tend to slow down a lot. But so you can back this down a little bit to keep things moving and hit the play button. And we'll see that the shape gets cut out. And when it finishes, I'll spin it around and we can see those holding tags. Okay, so you can see that here's the material that got left behind. In the simulation, it's fairly rough, but it's that's the accuracy that I'm dialing down. You get a little bit rougher model, but it runs a little faster and a little smoother. Maybe if your computer's more powerful than mine, it'll work fine at a high accuracy. Okay, at this point, if I say OK, this will leave this cut material shape in the tree. And the cut material is this thing in here. If you hit cancel on that previous dialog, this will be removed from the tree. But you can always just select it and delete. Okay, so that's that. Let's go out to the shop and cut one. You might have been wondering why in the when I was setting up the operation that I didn't set up an operation to do the chamfer on the edges, and the answer is that the Path Workbench actually has a chamfer operation, but it isn't in the version 17 that we're using for the tutorial. It's a new feature that's being included in version 18, so I decided to leave it out and just do the contour at this time. If you're interested in using a chamfer operation, you'll need to upgrade to the pre-release version 18, and you could do it from there. All right, I'm going to show you how the mill is set up. I've got a piece of stock clamped to the table. I've got my 1/8 inch cutter set up here, and that's about all there is to it. It's 1/8 inch aluminum, and I'll load up my job. I think you can see it here. So the profile comes in looking much as it did in Path as we were setting it up. So the next thing I would do is touch off my material to the top. When we set up the job, we actually specify that the stock was 4 millimeters thick. to give it a little bit of through cut depth. So what I need to do is touch off the top of the stock material at 4 millimeters. Then it'll start cutting down from that point, and it'll actually go through about 1 millimeter. So the final pass may not be actually necessary. I need to touch off the top of the material at 3 millimeters, and which I've done, and I should be ready to start now. And when I hit the play button, it'll retract for a tool change, start the spindle, and then proceed to the start location to start cutting. Full runtime on this job turned out to be a little over 8 minutes. I'm going to go ahead and speed up the video to about 20x normal time so we don't have to just watch the cutter move along slow. You'll see that I'm using a little bit of lubricant. This tiny little 1/8 inch cutter clogs up with the cutting chips really easily, and I broke a cutter on my first attempt. So I'm just using a little lubricant to keep things clear and brushing out from time to time with a brush. When the part comes out, you'll see that the holding tabs are just big enough to keep the piece in place, and the part easily breaks out by hand. A few minutes of filing to clean up those edges. They're not even visible anymore, and that's it. The part's finished. Well, this is a really simple thing, and I hope it's helpful to understand how the whole workflow works. If you'd like to see more of things like this, please let me know. Hope that was helpful.